So now we're going to be solving circular functions and we're going to be looking specifically at sine and cosine. So what I want you to do is to think back to the unit circle activity that we did, where we have the three triangles. So one was red, blue, and green. And I want you to think about the properties of each of those triangles. So just in case you can't remember, I'm just going to start by filling in the three right angle triangles that we've got here. So if we take a look at the first one, so we know that it's a right angle triangle, and the angle in here we'll start with is 45 degrees. So you've now done an activity where you had to convert degrees into radians. So we know that writing 45 degrees times by pi on 180 will give us pi on 2, which is 45 degrees in radians mode. Now, filling in the rest of the information for this right angle triangle, we know the hypotenuse length is 2, the adjacent is 1, and sorry, that should be root 2, and the opposite length is also 1. So moving on to the next right angle triangle, so I'm going to do my right angle there. The reference angle for this I'm going to make 30 degrees. And so filling in the rest of this, again, we know that the hypotenuse here is 2. The adjacent length is root 3, and the opposite length here is root 1. Is just 1. Now again, converting that 30 degrees into radians, I'm going to do 30 times pi on 180, and that's going to give me 60 degrees. And lucky last, filling in this right angle triangle. So I've got my right angle there. This here is going to be 60 degrees. And then all you're going to see now is me essentially flipping the opposite and the adjacent length of the second right angle triangle to give me the length that, the opposite and the adjacent of this third right angle triangle. So what I mean is this. And again, my hypotenuse is still going to be 2. Converting that 60 degrees into radians, so that's going to be 60 multiplied by pi on 180. Now, what we've just done is essentially helped us find a way to solve trigonometric equations. So that's essentially what we're going to be doing now. And what I'm going to introduce to you is the notion of a table of exact values. So what this means for us is that we've got two different ways we can solve trigonometric equations. A lot of people tend to prefer the visual method, which is drawing these three right angle triangles and then filling in the information and using them to help them solve trig functions. Another method people tend to use quite regularly is what we call our table of exact values. So as you can see here, I have pre-filled some of it. So for example, if the angle is 0, then obviously sine of 0 is just going to be 0. Cos of an angle that is 0 is just going to be 1. And tan of an angle that's 0 is just going to be 0. Now, just in case you can't remember why cos of 0, is 1, just think about this. Remember that with our unit circle here, all right, so there's 1, there's -1. We know our x-axis is also cos, so when the angle is 0, it's just going to be there, which is 1. So now filling in the information here, so let's refer to our relevant right angle triangles to help us fill everything out. So starting with an angle of pi on 6, so we know for sine that we're looking for our opposite over hypotenuse. So where the angle is pi on 6 or 30 degrees, we're looking at this right angle triangle here. So filling in my information, so sine pi on 6 is going to be 1 divided by 2. And then moving across, so cos of pi on 6 is going to give me, so that's ka root 3 on 2. And then moving on to tan, so that's toa. So again, tan of pi on 6 is equal to 1 on root 3. So now what I'd encourage you to do is go ahead and basically do this for the triangle pi on 4 and pi on 3 and check to see whether your solutions match mine. So what you can see here is now that we've pre-filled our table of exact values. So essentially what we've done is tabulated these three right angle triangles into a table. So another important thing to note is that trigonometric graphs are periodic in nature. Therefore, there are infinitely many solutions to any trig equation. Now, the way we counteract this is by solving equations over a specific domain. So when we talk about the domain, we're referring to our x values. So by restricting our domain, we can limit how many solutions that we're looking for. Now, before we go into solving some equations, I just want to recall a few things. So I'm going to start by drawing our unit circle here. So if we look here, a couple of things I want you to note is this. So we know that this is 0 degrees or 360 degrees. Now in radians mode, that will be 0 or 2 pi, because that basically symbolizes one full rotation. Now we know with a unit circle, obviously we are going in an anti-clockwise direction. So moving up in this direction, I'm going to say that this is now pi on 2, which is also known as 90 degrees. Now if we move again here, this is 180 degrees, or we call it pi in radians mode. And then down here, so we know it as 270 degrees, or this is known as 3 pi on 2. Now, a couple of things to note with this. Again, there is an acronym, so ASTC. So that means all angles in the first quadrant are positive. Sine is the only one that's positive in the second quadrant. Both tan and cos are negative. And then moving down in the third quadrant, tan is the only one that's positive. Both sine and cos are negative. And then in the fourth quadrant, cos is the only one that's positive. Both sine and tan are negative. So if I've got this as my angle, to find the angle in the second quadrant, we're going to do pi minus theta, or pi minus the angle, or we can do 180 degrees minus the angle. And then moving into the third quadrant, to find any angle in here, we're going to do pi plus the angle, or we're going to do 180 degrees plus the angle. And then to find the angle in the fourth quadrant, we're going to do 2 pi minus the angle if we're working in radians, or we're going to do 360 degrees minus the angle. Now, this is going to become important when we start to solve, so just keep this in mind. So moving on to the next page. So I've said here to solve the following equation where sine of x is equal to root 3 on 2. So what I've said here is that x is an element of 0 to 2 pi inclusive, and we call this restricting our domain. So by restricting our domain, I can make sure that I get only the solutions that exist between 0 to 2 pi. So before I actually go into solving this by hand, I'm just going to quickly draw your attention to the calculator screenshot I've got here. If you are going to use solve, which I would absolutely encourage you to do if you are able to use a calculator, is to make sure that one, you define the function, or you say solve in terms of x, but hopefully what you can see here is that I've drawn like a straight line. So that straight line is a button on your calculator, and then you can see I've done x is greater than 0 or less than 2 pi. So what that means is that I've basically restricted my domain in the calculator as well, and I've told it to only give me the solutions between 0 to 2 pi. So what you can see here is that because I've done that, the calculator's actually given me the two answers that we're basically going to work out now. So it's told us that x is equal to pi on 3 or 2 pi on 3. So let's do some working out and see whether or not we get those as an answer. So to solve the following equation, you can use your table of values. I'm going to draw the triangles. I prefer the triangle method, it's just easier for me. So there's my right angle triangle, and filling this in, so we know we're looking at a ratio of root 3 on 2. So that means my hypotenuse is 2. Sine requires us to use opposite and hypotenuse, so that means My reference angle is there, my opposite length is going to be root 3. So that means that the adjacent length is 1. And if we go back to our 3 triangles, the triangle that best matches this is the one that has the angle pi on 3. So my reference angle here is going to be pi on 3. So now, what that means is that sine pi on 3 is equal to root 3 on 2. But that's not all. So for this particular question, the way you would write it out is essentially you would go sine of inverse 1 root 3 on 2 is equal to pi on 3. Now we know that by using our triangle. However, what our triangle doesn't tell us is that there is going to be more than one solution. And especially because I've said that I need all solutions for x between 0 to 2 pi. So if we go back to our unit circle, so the one that I drew on the previous page, so I said that sine is positive in 2 quadrants, the first one and the second one. So you can see here that to find any solution in the second quadrant, we need to subtract the angle from pi. So I'm just going to copy this across to the next page. What we need is another solution. So the first one we found was pi on 3, so we're saying that that angle there is pi on 3, but we need the other one, so that's this angle here. So what I'm going to do is I'm basically going to go pi minus pi on 3 is equal to 2 pi on 3. And that's where I'm going to stop, because basically what I'm saying here is that for this particular unit circle, so for one full rotation, the two solutions for x that'll give us root 3 on 2 are going to be pi on 3 and 2 pi on 3. Now if you check what we got on our CAS calculator, you can see that we got exactly that, pi on 3 and 2 pi on 3. Another thing I'm going to draw your attention to real quick is the fact that my calculator is in radians mode. If you are going to be doing this, and this is obviously in radians, please make sure that your calculator is in radians mode. Alright, so now looking at this example here, we've been told to solve the following equation. Cos of 2x is equal to negative 1 on root 2. This time I've restricted the domain from 0 degrees to 360, so what you should be thinking is we're working in degrees mode. If you take a look at my calculator steps here, again you'll notice that I have changed it into the degrees mode from radians. And again, when I typed in solve, I restricted my domain from 0 to 360. Now you might be wondering why we've got 4 solutions instead of 2, and that's because we've halved the period. Now we're going to be talking about the period with respect to trigonometric functions when we start to look at sketching, but for the moment just keep in mind that the reason we have 4 solutions for this particular function is because I have halved the period. So I'll just write that here. Alright, so what I'm going to do is quickly paste the unit circle. So again, we know where we're looking. So if I write down the function, so I'm going to rewrite it as 2x is equal to the inverse of cos. So what I'm going to do here is actually redraw one of the right angle triangles, specifically the first one. So that's where it's got 45 degrees. I've got a hypotenuse of root 2, and then that's 1 and 1. And there's my right angle there. Now, if you're wondering how I know which right angle to draw, I would start by looking at the ratio directly. Have a look at the function. So it says it's cos. So we know that cos uses the acronym CAR. So that's going to be my adjacent length of 1 and my hypotenuse length of root 2. So that means that we're working with the 45 degrees. So I'm going to have 2x is equal to 45 degrees. However, keep in mind that we actually had a negative here. So what that means is that we can't actually accept 45 degrees as an answer because cos has to be negative. Taking a look at the unit circle here, We know cos is only positive in the first and the fourth quadrant, which means that it's negative in the second and third quadrant. So to find our angle in the second quadrant, I'm actually going to do 180 minus the 45 degrees, and that's going to give me 135. So I'm going to write 135 degrees there. And then the next one is going to be 180 plus 45 degrees, because to find any angle in the third quadrant, we add it to 180 degrees. So here I'm going to have 225. So I'm going to write here 225 degrees. Now we have two more solutions, and the way that we find that is basically add 360 degrees, which is a full revolution, to my first solution. And that's going to give me 495. Then I'm going to add 360 again to my second solution. And that's going to give me 585. So now writing this here, 585 degrees. I'm just going to move this over. Might have to write down here 585, but we're obviously not done yet because we are solving for x. So again here, I'm now going to divide everything by 2. And that basically tells me that for any of these values of x, the cos of 2x will equal -1 on root 2. So what I'd encourage you to do now is to go ahead and practice solving circular functions, and make sure you use your CAS calculator to help you solve them. Please take note of any domain or any restrictions that we've placed, because that will obviously help you determine how many solutions you need to find.